Alright, hey guys, we're working on part 7. This one's titled Automotive Beginnings, mainly because it's kind of like a pinewood derby car-esque, design from a block. You'll see we're going to make a block that's like 100 by 50, and then we're going to extrude it 50, and then we'll make some cuts to make it look like this aerodynamic car shape almost. Imagine like some axles and some wheels, maybe almost like a truck. But anyways, let's build this part and you'll see how it is done. Alright, so we're going to sketch on that front plane because that's how it looked in the ISO. Let's make a center rectangle box. Oh, I skipped that step. I've done that before. Quick fix. Cool. We said 50 tall, 100 wide. We extrude it 50 from the midplane. Put it in ISO so we know exactly what we're looking at here. So with this view, we can see that the back, because front, top, right, back, we're going to be able to get these angles and mirror them. One thing though, with that, you can always mirror within the sketch, or you can mirror the feature itself. So we're going to learn that one today. Some people swear by mirroring the feature and not the sketch, which I can understand the logic there, but I've never had issues doing either one. So there might be a specific time and place when you like to do it, or you find you like to do it. I don't have one. I could easily, just as easy, mirror this entity here and then extrude cut it, or we could just as simple extrude the cut to 25, I believe it was. Let's go blind for 25. And then we can, in the features menu, mirror, and because we just did that feature, it knows we want to mirror it. And because we mid-planed it, we can mirror it right across that front plane. Now we have the back of our device, our little beginnings of our block. So we've done the back half of it essentially, and we know the origin to be at the center like we've showed with the center point rectangle extruded outwards. So let's do this sloping feature here, and with this one you got to kind of know some stuff. You gotta know how to do a certain type of extruded cut and how to set it up. And those extruded cuts that are along a path, you have to set up that path, set up what you want to cut, and then combine them. So let's set up the path first. We know we want to be sketching in the front plane, but say you make a quick mistake and you click on that plane and then you draw your triangle. I believe it was in relation to this. So we're gonna actually make some relations. You see how those yellow lines completed, and I didn't have to dimension anything. That's because those relations set things into the points we already have that are related to the origin. So this could be the path, and it could work because the path is the right direction, and it makes everything. I believe it would work, but we did this on this face to show you this. We could close this, and now that we've realized that we've sketched on the wrong face or the wrong spot entirely because we want to sketch on a plane, we can edit that sketch plane and change it from the face. Just delete that out. Go to our menu here, front plane, and you'll see that it just jumps. Simple enough. Let's go back into that sketch though, because we don't need this. We don't need those lines, do we? We're not going to follow those lines, so we can simplify our design a bit. Let's go back to our drawing to understand why we use those yellow reference points that appeared earlier, and I'll show you that here. So this path, it's coming down here at what looks to be an angle that's directed towards that origin. It doesn't really say, but we know this corner piece, and we know this corner piece to exist, and we know the origin to be somewhere in the middle. So if we complete that triangle, you can see how that line would complete to where the origin would be. It's kind of a roundabout way of understanding this, but that's kind of how we can look at it. So let's now do that second part I talked about, where we have to draw what we want to cut. And with this one, let's go over to this view again and talk about kind of like what we just talked about, but we're going to start this way. Looking at the sketch, we know this face to be cut down and at an angle away from this top part of the box. This is the only top part of the box left. So we know this corner connects to that, and we know this is 25, so that's the center of it. We can think about the block still being there, thinking about cutting out from a block. We can put that line down there, and then we can complete this almost trapezoidal shape. Let's draw that in there and see what it looks like. And from that corner, that should be invisible because it isn't our sketch, to about where our origin is, because that's what it looked like on our sketch. It didn't really say, but let's look at that sketch and just kind of see. You can just kind of see. And this being here like this, it could be like this. This could be how you explain it. 45 degrees. That could be in there. That could be a little cleaner, honestly, yes, to tell you that's what it's going to. Because then if you made this line and put these two at 25, then you could complete the triangle by putting the angle in. So we have this. Let's now go and extrude cut it along that line. So you can see it wants to blind cut, but it doesn't have anything to follow. It's just blind cutting down. We could easily do that. But you could see that the blind cut comes down and doesn't complete where the line is. I believe if we go through all, that's better. That's what we want. Let's finish that. Now we have half of what we want. We learned this just a minute ago. Let's mirror our feature. It already knows we want that feature to mirror, and we know we're working across the front plane. Awesome. So we have that feature cut now. We have most of our arrow-shaped, aerodynamic car kind of looking. You can see the arrow in there, and like I mentioned before, car shape. We can now come to this sketch and hide it because we don't need to see that line in there. Now for the last portion, it looks like it's just cut up from the bottom at 45 degrees, 25 millimeters high. So that completes that triangle. So let's get that in there. And that would be from the bottom, right? So let's draw that there. We could go from the top, but the plane is going to be at an angle because now our top plane is at an angle. So if we sketch here, it'll extrude in at an angle unless we go through to this face. And that's more clicking, which we've talked about. We don't like more clicking. We know this is going to be 25, so we can bring that out there. We don't have that angle in there yet, but we can complete the triangle. Now let's put the angle in. We know it to be 45. 40? 40. Let's double check that. Check that. 40. Perfect. We can extrude cut, and we're already set to through all because that's what we did before. And we don't need to pick a path because it's straight up. And let's reuse this feature one last time on the front plane to make our car. Cool. One thing I want to do real fast just for the fun, let's do this. We could easily throw a couple circles in here. I don't know how big these Axel holes would be. We're just going to make this up on the fly. Let's say there'll be 10. Even some big axles, why not, right? And let's dimension this from here, 12.5. And let's make this 10. No, 7.5. It looked better down there, didn't it? And now we're going to make this one horizontal with this. And then we're just going to tell it the distance between these two. We'll chain dimension it. I don't like that weird number. Let's put 45 in. That makes our hood a little long, but that's okay. You know what we're going to do? We're going to extrude cut it all the way through. Cool. Now imagine you had some axles and some wheels on that, and you slide it right in, it would go right on the table like a little car. You could probably bring these up a little bit for the structural integrity of the device because it's a pretty slim little spot there, but say you did it in like, I don't know, cast iron or anything that would be, cast iron would be extremely durable and tough to break through. Do cast carbon steel. That sounds fun. All right, and I'll add that to the video earlier on, or I'll put it in the notes or something, so I don't think we talked about the material yet on it. But I believe that looks good. Let's go ISO, double check our looks. Just ignore those holes. Looks correct. All right. So that's like automotive beginnings. With this kind of information, we could, you could go out there, build a block and do a pinewood derby car in SolidWorks now, and then take that into the real world, and you'd have blueprints. You could, so far from what we learned, cut all this out, make your own design. It's going to be a little blocky and straight cuts, and you could sand these angles off or fillet them within the program, but we haven't talked about that. But in real life, if you had a block of wood and you made these cuts and put it into a drawing and printed it out, you could take that to the shop and build it. So think about real world applications of these things too. Pretty cool. All right, I think that's it for this video, guys. We will put the mass properties in the description for this item set with cast carbon steel. Thanks.